Thank you all for being here. There's been over 450 people registered. We have 70, almost every single European Neo employee is here today. It's over 500 graph enthusiasts in this room today. Quite amazing. So I always talk to the local Neo4j team about that, and to the local Neo4j community. I'm never as happy as to be in London, be back in London. It's out of all the places I can go and talk about graphs, this is my favorite graph city on the planet. And I'll tell you a little bit why, for a couple of reasons. So one is that, and I think this is quite amazing, this week the London user group, the Neo4j user group, crossed 2,000 people. 2,000 people. Which makes it, big round of applause, which makes it not only the biggest NoSQL, if you will, user group in Europe, but it's the biggest graph database user group on the planet. That's amazing. Well done, London. Well done, London. Second reason that I love being at GraphConnect Europe, here in Europe, is that I'm based in Silicon Valley now. We're headquartered in Silicon Valley, and that's where I'm based. But really our origin is in Europe, right? I'm Swedish. We started out in Sweden. We have 70 employees, as I mentioned, all across Europe. The origin is here, but more importantly, the product is built here. We have over 30 employees here today, the Neo engineering team, that wake up every day building what I believe is the best graph database on the planet. And all of them are here in this room. If you're part of the Neo engineering team, please raise your hand. So if you want to talk to the person who invented Cypher and controls what Cypher is going to look like today and tomorrow, he's going to be here. If you want to talk to the person who wrote much of the kernel, he's going to be here, etc. Use that. I think that's an amazing part of being at GraphConnect Europe, being able to talk firsthand with the people who actually build the product. It's been actually 2 years since we were last here in this shape, right? We have a lot of activity going on in London. Again, 2,000 people in the local meetup group. But in this shape, in the GraphConnect shape, it's been 2 years since 2013. And in fact, I thought we'd kick it off that way. Could everyone who was here at the first GraphConnect in London, 2012, I'm going to start with a little bit of morning gymnastics. Could everyone who was here at GraphConnect 2012 please stand up? Trick question, there was no GraphConnect in 2012 in London. However, there was one in 2013, so please stand up if you're here at GraphConnect 2013. All right, awesome. And anyone who was at GraphConnect, please remain standing. Anyone who was at GraphConnect in London 2015, please stand up. All right, stand up. Raise your hand, clap your hand, give yourselves a huge round of applause. Amazing. Standing ovations already. This is off to a great start. Cool. So I'm going to kick this off. I'm going to talk a little about a couple of things. Talk that I sort of tongue-in-cheek titled Graphs Are Eating the World. And you saw the ground rules before, turn off your phone and whatnot. I want to add one ground rule, which is really the only ground rule that I have for all of my talks, which is I do not want your undivided attention. Like another privilege you have being here in Europe versus Silicon Valley is that you have phones and they work here. It's an amazing thing. I almost forget it, and then I'm like, oh yeah, I can actually use the internet on my phone. Please use that. Tweet about this. Let me know how we're doing, good or bad. The only thing that I do ask of you is that you use the Neo4j hashtag. Neo4j, N-E-O, the number 4 and J. You will hear a lot about that throughout the day. Use that hashtag and let us know if we're doing good, if we're doing bad, feedback, comments, etc. Without further ado, I'm going to start interactively. I'm going to throw some logos on the slide. These are 6 companies, and I want you to interactively shout out what do these 6 companies have in common. Any suggestions? Graphs, great suggestion, great idea. The color blue, amazing pattern matching. They don't pay taxes. They don't pay taxes. That was awesome. I'm not going to comment on that. For more debates about that, that's the other event going on today, the election event. Web scale, love it. Yeah, I wanted to conclude with saying, like, all of what you said there was correct, but I'm not going to do that. Some of what you said was correct, and then there were some other political comments that I'm not going to comment on. Really, the one thing that these companies have in common is that they all said, look, data is incredibly valuable, but for a long time in our industry, we've looked at data in isolation, right? And these 6 companies are all market leaders. They've all won their category, and they won by using exactly one thing. What unifies them is that they took a shift in perspective and said that data in isolation is valuable, but connections between data is also valuable. And what if we take the connections in our data, the relationships in our data, and we reimagine our business along that? What is that going to look like? And nowhere is that, I think, more dramatic than in web search at the end of the 90s, right? Who remembers these companies? Excite, right? Excite, Alta Vista, Lycus, right? A few people remember them, right? End of the 90s, there were 50 search engines, right? And kids these days, when I talk to millennials these days, like pre-Google, that doesn't exist as a concept for them, right? But no, end of the 90s, there were 50 search engines out there. I grew up as a professional programmer in the mid-90s, and I remember looking what they did and being blown away. Basically, they're saying, like, okay, we have this new sort of data structure out there called the World Wide Web, and it's like doubling in size every third day or every week or some ridiculous metric like that, right? So what we're going to do, we being Lycus or Alta Vista or whatever, is that we're going to download the entire web, like every single document. We're going to download that into our data center, and then when someone searches for London, we're going to look inside each and every one of these documents. We're going to serve back that as a result to the user, right? And oh, by the way, we're going to do this, download the entire web. How frequently? Every day. For how often? In perpetuity. I just thought that, I looked at that, I was like, that's amazing. What an accomplishment, right? But then a small startup came along, right? And they said, we're going to do exactly what these guys did. But on top of that, we're going to also extract, we're going to look inside of every one of these documents, and we're going to find href links, right, HTML links. And we're going to extract that into a connected data structure, right? And we're going to conceptually say that if a lot of people link to one document, right, we're going to consider that a more important document. And we're going to rank them according to the connections in that data. And of course, that small startup was Google, which ended up completely dominating web search and became, at least what I believe, is the most fundamental and transformative company of the previous decade. There was one shift in perspective. Let's look at our data, let's reimagine our data along relationships, not just in isolation. Another example is Monster.com, job search. They basically say, hey, let's do online what we've always done when we look for a job, which is have a description of the job profile, have a CV, match them up together, right? Very successful, very awesome. Except then a small startup came along which said, no, actually in reality, what we have, and as human beings have always done when we look for occupation, is that we talk to our friends. And we ask our friends to talk to their friends. And what if I could get people to volunteer that information, not just about themselves, but about the relationships, the professional relationships that connect them to other individuals? That would be very powerful. And that small startup, of course, was LinkedIn, which is why LinkedIn today is, 50 times more valuable than Monster.com and dominates their market. Second example, and a more subtle example, I spent some amount of time thinking about connections in data, but I myself didn't realize this until I spoke to a specific gentleman called Reid Hoffman, who is a founder of a tiny little company that you've heard of for sure, but is online payments. So back in the 90s, a bunch of companies tried to do online payments. I should have localized this. Citibank, of course, is, I'm sure Citibank is available here as well. I happened to pick on them. It could be anyone. Tried to do online payments. Turns out that the key challenge to doing online payments is fraud. And fraud becomes really difficult to detect if your entire worldview is transaction, like a transaction consisting of transmitter, amount, receiver. And then you have another, transmitter, receiver, transmitter, amount, receiver, right? You have just these singular transactions, and you want to detect fraud. But then again, a tiny startup came along and said, what if we could take a graph view of this, a relationship view of this? And that tiny little startup was PayPal, right? And that's what allowed them to dominate the online payment space for a long time. 3 examples, all consumer web. What we're seeing at Neo4j very, very tangibly is this is now happening. It started out in consumer web, but it's now spreading across the entire industry. One example of this is logistics, and this is actually at the previous GraphConnect, we had someone talk about this, where a huge logistics company, 500,000 employees, so absolutely massive, who handles entire parcel routing, package routing, so letters, not letters, packages, but like physical packages that you send. Remember that you can do that? For an entire country in Europe. And the problem they had was that they saw that by Christmas time the following year, they would not be able to cope with the load. Because actually it turns out that sending physical packages, believe it or not, is increasing over time. And it's a highly seasonal business, of course, or in December, mid-December, that's the absolute peak load. And it's also when you absolutely do not, if you're a logistics provider handling parcel routing for a country, you do not want to go down there because you don't want to be the scapegoat who messed up Christmas. And what they saw was that they won't be able to deal with the load the following year, Christmas time. And when they started double-clicking on that, it turns out that the problem was not in the physical roads, the physical infrastructure of this country, which has amazing physical infrastructure. The problem was that their software system ended up sending all of the packages to a few central routing stations, routing centers. And so, for example, if you want to send something from point A to point B there, I don't know if you all can make it out, but there's an awesome road from point A to point B, but they had to send it all the way up top and then back down again. Which doesn't make sense because the physical infrastructure allowed them to do an amazing shortcut. And so they double-clicked on that, and it turned out that the key reason for that was that the database held them back. The database wasn't enabled to express all the richness that existed in the physical infrastructure, right? So they threw that out, a 20-year-old system using a relational database, and they built a system with a graph database, Neo4j, at its heart, right? Which then allowed them to go to express all of the richness of their physical infrastructure in their data, which allowed their routing to be as efficient as possible. Quite amazing. In this particular instance, then, one could say that graph databases and Neo4j in particular saved Christmas. Yay. One example, we see this spreading inside of logistics. Another example, retail. Like the Fortune 1 company, the biggest company on the planet is called Walmart, right? And they're going through a huge transformation right now when they're moving from physical retail, not away from physical retail, but they're transitioning into online retail. And what Amazon.com has taught the world is that when you do online retail, you want to do recommendations, right? Other people who bought this also bought that type stuff, right? And the problem they had is that they had an infrastructure where they had recorded purchase history forever. Huge amount of purchase history, but it was all kept in data structures that didn't allow them to explore connections, right? And it turns out that if you take a normal purchase history log and you look at that from a graph perspective, then you're going to see, hey, there's a customer called Emil, right? And he's purchased milk and beer and butter and I mean, all these different things, right? But then there's a customer called Volker, I'm going to pick on you, Volker, randomly, who's also bought milk and butter and beer, but in addition to that, he's bought a book. He's bought The Lord of the Rings by J.R.R. Tolkien, right? So then, what if we take that book and we recommend that back to Emil, right? Because supposedly we have the same sort of buying patterns, we're probably similar, have the same interest, let's just recommend that, right? That's a very graphic perspective, actually, because if you think about that, that's I don't know how many hops, 1, 2, 3, 4, 5, that's 11, 12 hops in that data structure. And actually, in reality, what you want to do is that you want to not look at that specific book, Lord of the Rings, but you want to look at that as part of a category, specifically fantasy books, which is part of a category called fiction books, which is part of a category called books. And then you want to recommend other things based on that category, right? Which adds a huge amount of complexity in terms of number of hops that you need to do, maybe 30, maybe 40. In a relational database with joins, that's a complete no-go, in particular if you want to do it in real time, right? And with Neo4j, you can do 1 to 2 million hops per second in a connected data structure, right? And online retail is one of the things that have completely taken off between today, 2015, GraphConnect 2015, and when we were last here in the GraphConnect forum in 2013, we did not have any retail, not a lot of retail traction back then. Today, 4 of the top 10 retailers on the planet, 4 of the top 10 biggest retailers on the planet are using Neo4j. I think that is pretty amazing. Recommendations, very strong use case for connected data. Third, Internet of Things. Should more aptly be called the Internet of Connected Things, right? Without the connections, there's no point to it. It turns out when you have a lot of connected things and you want to manage that, that's a somewhat graphy problem because it involves a lot of connections, right? So HP has a product in this space where you embed their product inside of big telcos. It sniffs network traffic. It builds up a model of the entire network, all the devices on the network, and then you can start figuring out, like, if all of these devices are flashing red at the same time, is it because all of them are simultaneously failing? Or is it because they're connected to this firewall, which is connected to this power supply, and this power supply has gone out, right? That type of real-time analysis, predictive, is what you can do if you take a connection view of the Internet of Things. So we see this very tangibly where vertical after vertical, industry after industry is starting to use connections in data. And once you start to use connections in data, it's a very high chance that you can build a better product. You have a much more nuanced view of the world, more sophisticated insight. You can use that to build a better product, have a better customer experience, thereby forcing other competitors who haven't moved on to use connections in data to start using them or lose, right? And that's very dramatically what we saw happen with Google and web search, where Google was the first one to get the idea of using connections to data, but then build a technology stack from the ground up to handle this, right? And all the other people, right, the Lycoses and the X-Sites who are more sort of almost like a punchline joke today, right? Who were super big companies back then, right? Did not manage to make it. So we see this, and we saw this actually when I was last here at GraphConnect 2013. We talked a little bit about what we thought were the hypotheses around the early adopters of graph databases. And from an early adoption perspective, we thought that there would be 3 key verticals: software and financial services and telecom, right? And then 4 key use cases for graph databases. And I'm happy now to show you sort of the scorecard where we are today. And these are some of the public users of Neo4j up and running in production, whose business completely relies on Neo4j today. And you can see big companies like Cisco and HP and 3 and SFR, one of the biggest telcos in France, TomTom, etc., Pitney Bowes. And then you can see small companies like Glassdoor and 53, etc. Pretty amazing. Very happy about this. What's been even more amazing is the traction that we've seen outside of these verticals, where we just see industry after industry being eaten by graphs, as we call it, because one company in there starts using graph technology, starts using connections in their data, and thereby build a better product. And that forces other people to start adopting it. Right? Graphs are eating the world. So that's kind of cool. Another thing that's been pretty amazing to see is the community traction. And I think that's very tangible here in London, like with 2,000, an active 2,000 members in the user group. But that is also happening globally. So what we see, there's a site out there called DB Engines, db-engines.com. Who knows DB Engines? Hand up. Few people. It basically does what I used to do manually, which is it tracks all of these hundreds of new database projects, right? There used to be only 4 databases. Now there's like 100 of them. It tracks them according to popularity measures, right? So you look at number of tweets mentioning the database, Indeed.com job postings, skill endorsements on LinkedIn, page rank, and a bunch of signals like that, and they compute a score. And more importantly, they compute a score for a specific category, right? And since 2013, most of 2013, and all of 2014 and 15, graph databases have been the fastest growing category in databases, which I think is quite amazing. Let's think about this for a while. Like big data or the data transformation going on right now is quite possibly the hottest part of the technology sector, bar none, right? And graph databases is the fastest growing category inside of this. So you, as early adopters of this technology, have been extraordinarily visionary to adopt this early. And I think this is a trend that will only continue. We used to have only community traction, right? Only actual users who got value from the database back in 2013. Today, we're seeing also analysts and other people who observe the industry that talk about the transformative value of graphs. So this, I think this quote by Gartner is extraordinary. They talk about graph analysis as the single most effective competitive differentiator outside of getting data in the first place, right? And Forrester talks about that in just a few years, over 1/4 of all enterprises will be using graph databases in production, right? Quite amazing. But much more importantly is the feedback that we get from users, people who use the technology every day and who like it, and they choose to comment on it. And these are some of the quotes from people who have adopted Neo4j in the past year or so that I think speaks to the quality of what we're trying to achieve with the product. So that's awesome. Graph databases are taking off, huge traction, etc. But let's take a step back. What is a graph database? What are graphs, right? So one change here in 2015 is that when we did a survey, a pre-conference survey, and I'm sure many of you have submitted to that survey, 70% actually in this room are people who are either using a graph database in production or developing an application on top of Neo4j today to be put in production. Which, I mean, just a few years ago, that used to be 10% or 5% or something like that. So that's very cool. But for the third or so who haven't heard of graph databases, let me walk you through sort of the fundamental concepts. In a graph database, we always want to start to model something, right? As with any database. So let's assume that we have a very, very simple domain. We have a girl who loves a guy. That's our simple domain. And not just any girl. This is someone who's called Anne. And Anne loves Dan, right? Very simple. If we wanted to express this using graph primitives, we like to kind of draw circles and draw arrows, right? We call the circles nodes. We call the arrows relationships. So we say, Anne loves Dan. Very easy, very simple to whiteboard. However, if you want to express this using a keyboard, I mean, we sometimes talk about graph databases as being whiteboard friendly, right? But what about keyboard friendly? How would you express this using a keyboard? Well, we then turn to ASCII art. I don't know if anyone in this room remembers ASCII art, but if you wanted to draw this little graphic over here using a keyboard, you can imagine that you use parentheses for nodes. So Anne we wrap her in parentheses to draw that circle. And then we draw the arrow using minus, minus, and greater than sign. Anne loves Dan. So you can sort of see that, yeah, that sort of looks the same, right? And in fact, if we wanted to add some data to this, we can do that using sort of JSON-ish syntax where we say that, hey, let's add a name colon Anne in there to add that the actual attribute of the node. And let's add label to that node. It's not just a generic node, it's a person node, right? It's Anne, she's a person. So we denote that using the colon syntax. This, when you start using this syntax, right, or in this pattern, you can see something emerging, which is the pattern saying node, relationship, node, right? And really all that you do when you're graphing data is that you identify the pattern of here's an entity with a link to another entity, node, relationship, node, and then you have this node connecting to other nodes, and all of a sudden you have a graph, right? It's as simple as that. And this syntax we call Cypher, right? It's the query language with which you interact with graph databases, or specifically Neo4j. And let's say that we wanted to not just prescribe this data structure, but we actually wanted to run a query. So let's say, whom does Anne love, right? Then we would, rather than putting Dan in there, we would replace that with a variable, call that variable whom. We'd wrap that in a match clause, which is part of the syntax of Cypher. We say match this little subgraph, Anne loves question mark, and then return that question mark. Simple as that. You draw using ASCII art this little pattern, and then you throw it to Neo4j. It's going to find instances of that pattern and return it as a result back to the user. So that's awesome. And it's a neat way, or if you have a domain that involves a lot of connections, it's a neat way of expressing that. It gives you a number of benefits in terms of agility and time to development and all those good things. But what was even more dramatic, I think, is the performance benefits that you get from using a database like Neo4j if you have connections. And this is an example that I've talked through, for 4 or 5 years now. It's almost folklore, right? And it dates back to the origin of Neo4j. And it's a really illustrative example around the type of performance benefits that you can get if you choose a technology that is fit for the problem at hand. So the problem was, the situation was that we were contacted many years ago now by a huge social network that you've heard of, which said, we've looked at all these emerging new types of databases, and we love them, they're amazing, yada, yada. But really, our world is a graph, right? And your domain fits perfectly with that. So, however, we're a huge social network X, so rather than, we just adopting you based on the model, we really only care about the performance, right? So can you show us some benchmarks, right? And us being the honest Swedish geeks that we were, back in the days, we said benchmarks. You can prove anything with benchmarks, right? You know the saying of there's lies, there's damn lies, there's statistics, and then there's benchmarks, right? So we said, no, we're not going to do that. However, if you give us a scenario that is relevant to you, then we'll implement that and we'll show our numbers, right? And the scenario they gave us was the following, right? So imagine that you have 1,000 people. Every individual has 50 friends on average, right? So 25,000 total connections. Grab 2 people at random and check to see if they're connected. Of course, we all know that there's 6 degrees of separation. Everyone's connected to everyone. So let's cap it at 4, at depth 4, right? Check to see if they're connected at depth 4. We implemented this using another Swedish open source database called MySQL. And it was a 2,000 millisecond operation, which is pretty significant because this is not a big graph. It's 1,000 people, right? And this is slow enough that you can't use this as real time when you render a page in a web application, right? In Neo4j, this is a 2 millisecond operation. Pretty significant, 1,000 times faster. But we didn't stop there. We added a little bit more data to it. So we actually added 1 million people into the graph and 50 friends on average, so 25 million connections. Grab 2 people at random, check to see if they're connected depth 4, and it's still a 2 millisecond operation. 1,000 times as fast on 1,000 times as much data. And in MySQL, we kept it running and killed it off a few weeks later. And it's easy to construct a similar query where we would be much slower than MySQL. The point is not that Neo4j is faster than MySQL or whatever database for any situation. The point is that if the shape of your data and your queries are graphs or where relationships are important, then you can get these amazing type of performance benefits and do things in real time that you had to do as an offline job if you could do it at all in a previous generation of technologies. So that's cool. It looks great on slides. But what does it look like in the real world? So when you install Neo4j and you run it locally, you get this nice little experience. We call this the Neo4j browser, and it's an integrated and interactive, both learning experience and full-blown developer experience for Neo4j, right? It's very simple. It has a query bar at the top where you type Cypher queries. You hit enter, and you're going to get the result set back, and you can explore that result set, right? Very simple. But it also includes a number of interesting learning material, right? Which is built into the product, which explains the fundamentals of the product. You have nodes, you have labels, more nodes, relationships, properties, etc. It has intro to the Cypher query language, small tutorial where you can do a bunch of things, and if you want to run them, you just click on this and you can run it interactively. Usually there's syntax highlighting, but for projector reasons, I have a different color scheme today. So that's very neat, and people love the fact that you can actually learn inside of the actual product. But you can also, as per Neo4j 2.2, we include a number of code examples, and not just code examples, but data as well. right? So the movie graph is a little toy data set of a bunch of movies, for example, The Matrix, which I happen to like. The founder of Neo Technology happens to like The Matrix. It's a huge surprise to everyone. And do like some queries and actually a recommendation engine on actors in a few lines of Cypher. I think it's 2 lines of Cypher that does that recommendation engine, which I think is pretty amazing. So that's been there for a while. In 2.2, which was very recently released a couple of months ago, we include what's called Northwind, a Northwind data set. How many in here have heard of Northwind? Raise your hand. Most people, awesome. It's the prototypical RDBMS sample data set, right? It's included in SQL Server. It's this food purveyor called Northwind, which basically sells food products. So there's products in there. There's a supplier of those products. There's customers that place orders on those products, and that's pretty much it, right? Actually, that's not it. It's much more sophisticated than that. But it's the one example that people use to talk about when you use an example for relational databases. Turns out that when you think about what I just said, what did I just say? Well, there's a product which is being purchased by a customer through an order, and that product is supplied by a supplier, and the product belongs to a category. This looks awfully like a graph, doesn't it? Right? What if we wanted to make a super simple query? For example, which of the suppliers produce or sell produce, right? So a category of produce, which supplier supplies that, right? Then you have to start with category, go to product. There may be multiple categories connecting to suppliers. That's already 2 or 3 hops in that graph, right? Hops means joins in a relational database, typically not the forte of a relational database, at least not at scale with performance. That's kind of interesting to look at. So what we've done in Neo4j 2.2 is that we've included Northwind from scratch as a way of taking what people may think of as a very relational data set and importing that in Neo4j. So it goes through how you use the load CSV command from Neo4j 2.1 to take a CSV file, import that into Neo4j. You click here, and then you run that, and it's going to import it, and it goes through, and it runs a number of queries, etc., in order to walk you through how to take that tabular data set, transform it into a graph, and then run queries on it, right? So let's have a little peek at that data set. Let's look at customer. So I just clicked on the label customer in order to get the top 20, or no, not the top 20, 25 randomly chosen customers that we can look at. It's a graph, not a very exciting graph. It doesn't have a lot of relationships. It's still a graph, but without nodes, not very exciting. But we can look at them, right? So I don't know if you can make this out, but actually in here, we have Anne, our friend Anne from before, right? Remember we said Anne loves Dan? And she's actually from Northwind, it turns out. Isn't that crazy? You can explore that. You can double-click. Here are the things that Anne has bought, the orders, right? You can double-click on them. And here you find, what do you find? Coffee, mozzarella, and she's also very interested in buying Uncle Bob's organic dried pears. Who else is interested in that? You double-click on that, man. Okay, that was a very popular product, clearly. This is produce, we talked about before, part of the category produce. And apparently Elizabeth Lincoln and Roland Mendel and Maria Larson also likes to buy these type of things. You can start clicking around and exploring your data set like this very, very interactively. So that's cool. But what if you wanted to do a little bit of a more graphic query? Like if you had this data set at hand and you're a business, you might want to do something like recommendations, right? It turns out, believe it or not, when you look into Anne in the classic Northwind data set that ships with SQL Server, and you look at where she's from, the city says London. So not only is Anne the prototypical example we're using, it's actually local to you guys. Isn't that amazing? So a query that we may want to do is something like, hey, let's look at all the products that are popular right now in London, filter out the products that Anne has already bought, and then recommend the most popular ones to her, right? Makes sense. So that query in Neo4j using Cypher looks like this, right? So what are we doing here? We're looking at customers who have the city London. Through the orders, what are the products that they have bought? Filter out Anne's products, the products that she's already purchased. Then rank them according to number of orders, so popularity specifically in London, right? Once you get used to the ASCII art Cypher syntax, it's super easy to see, right? So we run this little query, and we get the result back. 5 products, the top 5 products bought in London right now, and we can look at which is the most popular of all of them, which to the local crew, I'm sure is going to be a huge surprise. It's a lager, it's beer. It's the most popular product. This is the pure, unadulterated Northwind dataset. Anne happens to live in London. The most popular products that she hasn't bought in London right now is beer. I mean, that's poetry in my mind, right? Graph poetry. And so we can look at that, and we can explore that graph a little bit more. So this is the logger, right? So let's look at the logger. There's a bunch of orders. It's supplied by a supplier called Pavlova. It's part of the beverage category. Here's that other, here's the other product. We can traverse through that and start exploring our domain, right? So let's take a step back. So what I've showed you right now is the developer experience that we built in Neo4j 2.x, right? It was launched in 2.0 along with a number of really important features. 2.0 did fundamental work on the data model. We added labels. We added indexing, making Cypher a first-class citizen. You could work with indexes in Cypher, which you previously couldn't do. And then it included the Neo4j browser experience. Myself, personally, I think working with graphs is kind of fun, a little bit. It's one of my things that I like a little bit, let's say. And just personally for me, the Neo4j browser experience has been made working with graphs 10 times as fun. It's just super convenient. It's right there. It ships with the product. It lives in your web browser. It's super interactive. You get visualization. You work with data. It's quite amazing. Over time, you start accumulating a lot of scripts, right? The Cypher scripts. And it's awesome that you can, inside the browser, you can create a little script. Let's do GraphConnect Europe script, and it's match. Oh. It's match and return and limit 10, right? A script like this, which we can run, but then we can also save that. And we get the GraphConnect EU script here, right? Which is amazing, right? And over time, you start using this, and you have hundreds of these kind of scripts. However, a challenge with the fact that this is included in the product and lives in the web browser is that it lives in the web browser. So if you lose your web browser, like all the scripts are gone, right? Like this happened to me a few months ago. My laptop got stolen, right? And I had probably an order of magnitude 100 Cypher scripts in my browser. And 8 of them were crap, honestly, right? Just stuff that I played around with. But 20 of them were really valuable, right? And they were gone, right? So I had to literally recreate them from scratch, right? Which kind of sucks, right? And we've seen this happen time and time and again, and a lot of people have talked to us about this. So what we're working on right now, I'm going to give you a little preview of something that we won't launch today, but something that we're working on right now, and we will launch this year, which is called Neo4j Sync, which is a way of synchronizing Cypher script between your various web clients, right? So let's say that we launch a new web browser in an incognito window, right? This is Chrome incog mode. As you can see, this is the absolute first experience, right? Neo4j. Now all of a sudden, in this particular branch of the product, there's a way you can log in using Neo4j Sync, right? So you can log on here using GitHub or your Google account or Twitter or something like this. Let's choose GitHub as an example. Most developers have a GitHub account. This is incog, so I'm not logged in. So let's do that. And then all of a sudden, the Cypher scripts that did not exist previously are now available here in this new web browser, which of course now is on my local machine, but could be like my next laptop if when this laptop gets stolen, right? Or on another machine. And you see the script that I just created, the GraphConnect EU script is available right there. We can drag that into the Northwind folder. We can see how it then moves into there. And in fact, it will even open and collapse sync-wise at the same time. So this is one first step that we're taking towards making the Neo4j integrated developer experience more smooth and cross-platform and cross-devices. This is something that we're very excited about. It's a first step out of many, but we're going to launch it this year, and in a very staged approach. There's a wait list available on neo4j.com/neo4j-sync, and we're going to release it to 10 people in the first batch, and then 30 people, and then 100 people. So if you want to be part of evaluating this and help us co-build this feature and give us feedback on it, please sign up on this page. The other thing, very exciting thing that has happened, and we have two very special individuals here today, Ian Robinson and Jim Weber, who's written an amazing book, which has ended up being the de facto book about graph databases, the O'Reilly book about graph databases. We're now releasing an updated version of this one, which, the first version was written with Cypher 1.9, which was pre the 2.x series, and Cypher has evolved a lot since then, and has now been completely revised by Jim and Ian and the developer evangelism team to be upgraded to Cypher 2.x. This one is available today. We have 25 copies here today, and we're going to do a little competition. So the competition, if you want to get the top 5 people who tweet about Neo4j or GraphConnect today using the Neo4j hashtag, we're going to arbitrarily choose 5 most amazing, funny, extraordinary, exciting, insightful, etc. tweets. And the top 5 people will get a signed copy by none other than Ian Robinson. Please stand up, Ian, and wave to the people. And Jim Weber is already standing. Signed copy about this amazing book. So we have 5 minutes left. The new employees and the organizers of the conference are shocked that I'm getting to the end of my talk 5 minutes ahead of time. But I want to conclude on sort of this particular note. I have one piece of homework that I always give out at GraphConnect, which is sort of the mission at GraphConnect. But before we get to that, to your one piece of homework for today, I want to ask a question again, which is, and no need to use my intense vulnerability here now in the scene and the attachment that I have to a specific product in this category, but which is the most powerful database in the universe? That's my question. Throw it out. No need to raise your hand. Give me an example. Yeah, go ahead.
The brain.
The brain. This guy has seen my presentations before. The human brain. The human brain. The most powerful database on the planet. Why? Because physically, how does the brain work? Neurons, synapses to other neurons, which builds up a graph, right? Physically, that's how our brains are wired. They're graphs. And also, philosophically, I believe that's how brains work, right? You're trying to figure me out right now. Who's this guy on stage talking about graph databases? And if I tell you some data on me, first name Emil, last name Eifrem, age 36, that tells you something about me. You now learned stuff about me. But if I tell you how I relate to the world, I grew up in Sweden, I live in Silicon Valley, I'm married to Madeline, I'm father of Naomi, I play the piano, I listen to Mozart, like all those things, it's what gives me color. It makes you understand me, right? And that was all about relationships. And I think what the human brain does in order to figure out unknown concepts, they do that by relating it to known concepts. It's all about the connections. So there's one thing that unifies, I think, all of us in this room as graph database enthusiasts, but honestly as human beings. It's our ability to relate. So your mission then is to connect. And I want to echo what Rick said. Don't be a tragically isolated document. Don't be a lonely key value pair. At GraphConnect, I want you all to connect with people and form human relationships. So strike up a conversation with the guy next to you in the line or the girl next to you in the seat and ask, hey, how did you encounter Neo4j? Have you built something with it? Who did you vote for in the election? Or maybe not that. I don't know. But strike up a conversation, form real relationships, and connect. Have a fantastic GraphConnect. Thank you very much.